Okay, so we just calculated the energy for the first position. Now we're going to go ahead and calculate the energy for the second position. So the jumper has fallen. Well, he's mid-air. He has gone from 25 meters. He's now at 20 meters in position 2. And because he's falling, some of the gravitational energy is now kinetic. So now we need to calculate the amount of energy that is gravitational, and we also need to calculate how much is kinetic. We do know that the elastic energy is 0, right? The bungee cord has not stretched yet. So what I recommend you do when you are given a problem like this is actually look for the zeros first and put those zeros in, which is already done for you here. Okay, once you find those zeros, that makes your job easier, right? Because now you know you only have to calculate for 2. So our directions tell us to calculate the missing gravitational before we figure out the other 2. That's important because this is the easiest equation that we're given, right? Easiest. And there's another reason why which I'll explain in a minute. So at position 2, his mass has not changed, or her mass. It's 4, right? The gravity hasn't changed either, so that's 10. But the height has changed, so it is 20. And 4 times 10 is 40. 40 times 2 is 80 plus another 0. So we get 800 joules of energy here. And since now we know that it's 800 joules, we know that we need to get up to 1,000 joules because that's how much energy we have in the total system. The missing energy, the quote missing energy, is really not missing at all. It's accounted for here in the kinetic energy. So we don't even need to use this equation, the kinetic energy equation. We don't even need to use it because the law of conservation of energy, we can take the total starting energy, subtract the energy that's accounted for here, minus the energy that's accounted for here, which is 0. So 1,000 minus 800 minus 0, you get 200. Okay, and if we double check, 800 plus 200 needs to equal 1,000, which it does. In position 3, this one's actually the trickiest. This one is the one that students kind of struggle with a little bit because this is the position where we have to account for every single energy. None of them are 0. So now the jumper is almost at the end. They are 7 meters above the ground. So they still have gravitational. They're still moving, so they have kinetic. And the bungee cord is starting to stretch, so we have elastic energy here as well. So the first one is done for us. Mass times gravity times height. So their mass 4, gravity 10 times, ooh, there's an error there. Let's just assume that this is 8. Sorry for the error. I didn't catch that. So 4 times 10 times 8 is 280. Okay. So now that we know that we have 280 joules accounted for, we are missing 720 joules, and we need to figure out how much of each belongs to kinetic and how much belongs to elastic. So for kinetic, we know that our starting energy was 1,000, and we have accounted for 280. What we don't know is how much elastic energy there is. So this we need to find out in order to figure out how much kinetic energy there is. So we're going to skip this for now. Let's jump down to elastic. Actually, before I do that, I want to explain to you why we can't use this equation here. If you look at this equation, I'm going to zoom in here. Kinetic energy is equal to 1/2 mass v squared. We know the jumper's mass, right? It's 4 kilograms. What we don't know is the person's velocity. And there's really no way of knowing because it's not given to us and we can't measure it. So we can't use this equation actually at all. I'm going to find a So you will not actually be using this equation during your quiz. Okay, so this equation is important and we will use it later on in the unit, but for this quiz, you don't need to worry about it. Okay, so because we don't know the jumper's velocity, we can't use that equation. So we have to do the process of elimination. So let's jump now to the elastic energy. So let's see if we can use this equation. So elastic energy is equal to the spring constant times the distance stretched squared. The spring constant is given to us. Sorry. The spring constant is given to us, right? They're telling us that the spring constant of the rubber band, or the bungee cord in this case, is 50 newtons per meter. So we have that. And then if you look down here, they actually give us the stretch right here. So we have all of the information we need to calculate it. So elastic energy is equal to 50 times the stretch squared. I'm just going to use a caret to note the exponent. So we can calculate this. Remember, order of operations tells us that we need to do the exponent first. So 2 squared is 4. And then 4 times 50 is going to be 4 times 5 is 20 plus another 0 is 200 joules. Okay, so we just figured out how many joules of energy we have for elastic. So we can go back up here and we know now that this is 200. Okay, so 1,000 minus 200 is 800, minus another 200 is 600, minus 80 is 520 joules. Okay, we're almost there. Let's check our work here before we move on. So just to double check, 280 plus 520. So 500 plus 200 is 700. 780 plus 20 is 800. And then we have the 200 here. So when we add all of these up, it equals to our original. Perfect, so we're on the right track. All right, in the last position now, we do have a 0, so we put in the 0 here for kinetic energy. Okay, gravitational is calculated for us, so we're at 5 meters now. So mass times gravity times height, we have 4 times 10 times 5, which equals to 200. Since we don't have any kinetic energy, this is easy. We can take the original 1,000, subtract the 200 we just calculated. We know there's no kinetic energy, so that's 0. So the remainder then is 800 joules of elastic energy. Okay, you just found all of the energy in each position. The last thing you need to do here is determine the stretch at position 4. So this is saying at position 4 you have 800 joules of elastic energy. How much did the string stretch, the rubber band stretch? So we're going to need the elastic energy equation. Elastic energy is equal to the spring constant times the distance stretched squared. If you highlight the 2 and hit command period, that will turn it into an exponent. So this here, the distance stretched, is what we're looking for. I'm going to pause the video now. I want you to try to figure this out on your own. Solve for D after you plug in all the information that you do know.